Investments can increase or decrease in value. The value of a particular investment of €100 was found to fit the following model: V equals 100 plus 45t minus 1.5t squared. Where V is the value of the investment in euro and t is the time in months after the investment was made, find the rate at which the value of the investment was changing after 6 months. Now, the rate in this question is the rate of change of V with respect to time. That's the derivative, dv dt. The change in the investment, that's dv, divided by the time taken for that change to occur, which is dt. So we differentiate this function. If we differentiate 100, which is a constant, we get 0. Differentiating 45t with respect to t gives 45. To differentiate the next term with respect to t, we have 2 by minus 1.5 is minus 3 times t to the power of 2 minus 1, which is 1. This is the rate at which the value of the investment is changing at any time t. Now we're interested in a particular time t. We're interested in the time t equals 6 months. So t is in months. So we want to find out dv dt when t equals 6. So we just plug 6 into this. We get 27. Now the units here are euros over months. V is in euros, it's the value of the investment. T is in months. So the units for this value are euros per month. So that's the rate at the instant that t equals 6. Of course, that rate will change. State whether the value of the investment was increasing or decreasing after 18 months. Justify your answer. To answer this question, we look at the rate of change of V with respect to t at t equals 18 months. If this rate of change is positive, it means that V is increasing at t equals 18 months. If dv dt is negative, it means that V is decreasing at t equals 18 months. If you want to understand why we get the derivative, you could consider the graph of V against t. So over here I've drawn a rough sketch of this graph. Now you don't actually have to do this to answer the question, I'm just explaining why we get the derivative. Now this thing is actually a parabola because it's got a t squared term, and the t squared term is negative. So it's an upside down or inverted parabola. It actually crosses the v-axis at plus 100 at this number here. But don't worry too much about where this comes from. Just to explain what we're trying to do here, we're interested in seeing whether the v is increasing or decreasing at t equals 18. So let's suppose 18 is over here. And we can see that as time goes on, beyond 18 months, v is actually decreasing. The graph is, v is going down. That's actually the case, as we'll see when we calculate this derivative. When we calculate dv dt, we're getting the slope of a tangent to the curve. If that tangent is going this direction, sloping this way, then its slope is negative. And that's what we'll see. So the slope of this line is the derivative at t equals 18. So let's calculate this. We just copy this and replace t with 18. Working this out, we get minus 9. We get something negative. So the tangent has negative slope, so that means that v, the graph of v, that's this parabola, is decreasing when t equals 18. So all we do is we take the derivative and see if the result is positive or negative. In this case it's less than 0, it's negative, so v is decreasing. We got a value that was greater than 0, we would conclude that v is increasing. For example, at say a value of t over here, we would see that v is increasing, and we would see that the derivative or the slope of this tangent is positive. Here's another value. Now, say this value here is the t value of the maximum value of v. In this case, the derivative is 0. When the derivative is 0, v is neither increasing nor decreasing. But anyway, we have this question done. the investment was cashed in at the end of 24 months, how much was it worth at that time? So we want to find out what V is when t equals 24. We could write it like this: V of 24. V is a function of time. So we want to find V when t is 24. Just plug 24 in here. This gives 316 euros. We could show this on the graph of V, which you don't have to draw, but I've drawn it here. It's actually quite straightforward to draw since this is a quadratic function. Its graph is a parabola. At t equals 24, V equals 316. So somewhere along here, t is 24. And if we go up to the graph, we are at a V value of 316. Now, where this value is exactly, I don't know. So maybe I'll leave it out for now. And we look at the next question. How much was the investment worth when it had its maximum value? Well, I've already mentioned that previously. The maximum value is the value of t for which the derivative is 0, for which the slope of the tangent to the curve is 0. In other words, we have a horizontal tangent that occurs at the maximum value of v, the maximum value of the graph of v. So, to find the maximum or minimum of a function, we set the derivative equal to 0. We know what the derivative of this function is. We had it already. dv dt is 45 minus 3 times t. Put this equal to 0, and if we solve, we can find the value of t that gives that maximum value of v. From this we get 3t equals 45, so t equals 15. So, when the time is 15 months, v has reached its maximum value. The question is, what is this maximum value? What is this value here? Well, we want to find the v value of this point. This is a point on the graph of v. So the coordinates of this point must satisfy this function here. So what we've got to do is find the value of v when t is 15. So we just plug 15 into this function. We get 437.5, and this is euros. So the coordinates of the maximum value of this graph are 15, 437.5.